What's up, guys? Welcome to another video in our Arduino series. We're going to be looking at another one of their examples. This one is a music example. It's going to be on creating melodies with the Arduino. Now, instead of just taking the straightaway example that you get in their example code and using it and just describing that to you verbatim, I'm going to, of course, spice it up a little bit and change it around and make it a little different, so as to make it interesting. What we're going to be doing is we're going to be basically hanging a speaker off of our Arduino, and we're going to be producing some simple little tones. In fact, it'll make you reminisce to the days of the 8-bit sound days, you know, with the old 8-bit music and, you know, little melodies that went on for like your Game Boy and Nintendo and so on and so forth. And you guys will probably like the song that I picked to play for this, but basically it's very simple to do. What they're doing essentially is we are taking a digital pin and we are going to be toggling that pin at different frequencies to produce the different tones. So basically we're generating square waves is what we're going to be generating with this thing, and that more or less works good enough to create an audio pattern. So what I've done is I have gone ahead and put a speaker, which I just had some of this. I'm not using this AL60P, whatever that is. I'm not using that specific type of speaker. It was just a symbol that was in my CAD software, so I just used it. But what I am actually using is Multicomp makes a piezo speaker that I'm going to be using. Some that I ordered for another project that I made that, you know, I actually, it was the wrong one for it, and so I just ended up just keeping them just in case I'd need them. And lo and behold, I found this, so figured might as well put them to use. Anyway, so I got that out. Now, those of you that don't know what a piezo speaker is, they're usually a pretty small little. They can get large. The one that I have is fairly good size, but they're usually a small little black cylinder with like a little pinhole in the middle of them. And what they are is they're basically a little crystal that's inside that when you pass any type of audio waveform through them, they oscillate, and it creates it vibrates in there, and it creates the tone that you're hearing. So anyway, that's essentially what I've got. I put a little 100 ohm resistor in for kind of a current shunt resistor for it. And then we just put it on pin D8 of the digital side to ground. And that's basically all you got to do. And like I said, what we'll do is we'll toggle pin 8, digital pin 8, at different frequencies to produce different tones out of our speaker. Now, for me, like I said, I changed it around the example. What I did was on the example, they just put all of this in the setup portion of the code, and so what that does is it makes it only play when it first starts up. So it's kind of a real pain if you want to play the tone again. You have to push the reset button or power cycle it, or something, and of course you got to wait for the thing to like boot up again. Well, instead of doing that, I put an external push button on it and just kind of combined a push button along with all this. And so I've hung a push button off of the digital pin 12 just to ground. And then what I've done is then in the code I've issued that digital pin as an internal pull up. So that way it will pull the pin to a high, and then when you push the button, pulls it to a low. Your basic pull up network, and then it makes it. Then I can see that change. So that's essentially all there is to the hardware. This one is very, very simple. Most of the Arduino ones I'll probably be showing will be very simple. But on into the coding portion of it, I'll go ahead and bring up our sketch here. And if those of you can see the title of it, you can see what melody I've done. I'm not going to say it yet until I show it to you. But anyway, what this does is this calls the pitches.h header file, which is right here. And what that is this is all the different frequencies for the different notes that you can play. And what I mean by that is it's based off of basically like just general music, or basically a piano. And for those of you that don't play piano or haven't ever played a musical instrument, I had to go brush up on my stuff again because I haven't played an instrument in many years. But still, what we got, I got this picture for you, and hopefully we can see it. It's not too blurry. On a keyboard, you have, of course, all your different keys, and you have a C key that we call middle C. Now, with middle C, what middle C is the breaking point between the treble clef and the bass clef. Okay, anything to the right of middle C is the treble clef, to the left of middle C is the bass clef. So now you have, and then of course you've got octaves, okay? And what an octave is, those of you that don't know, real quick, like I said, we're just kind of doing a basic music overview. An octave is, obviously, it's octa, so it's the number 8's in there somewhere. Well, from one C to another C, because there's multiple of the same keys on a piano, but from one C, let's say we're starting at middle C, from one C to the next C, there's 8 keys, inclusively. So there's 1, 2, 3, 4, 5, 6, 7, 8 keys. That is an octave. Okay, so when you're talking in octaves, if you're talking, well, are you talking this C or this C or this C? Which C are you talking about? A first octave, second octave, third octave, fourth octave, fifth octave, sixth octave. Which one are you talking about? That's what an octave is where you're at on the keyboard. So from C to C is an octave. Okay. Now, if we look at this picture, hopefully I can blow that up. Hopefully you can see that. If you can't, it's okay. I'll explain it anyway. Here's our middle C. Okay, here's our middle C. Middle C is C4. Okay, is the middle C, and 4, I believe, if I remember right, means fourth octave. Okay, and we've got it at, let's see, what is it at? It's 261.63 is the frequency. If we look over here where my mouse is, they've got 262. So what they've done is they've just rounded up all the numbers. So again, middle C was 261.63. Well, if you round up, that's 262, and there you go, 262 is C4, and so on and so forth, and the sharps and everything like that. Now, those of you that don't know music, if you ever see a flat in a musical score, it depends on where you're at. So like, let's say it is, I don't know. Let's say it's a B flat. Okay. Well, if you notice, there's no. I don't know if you can see this. Hopefully this comes out okay. But if you can't see it, there are no flats on here. It only shows sharps. And if you look at the note description, it has a DS3, a CS3, AS2, so on and so forth. There's an S in there that stands for sharp. That's the sharps. Okay. Now, depending on where you are in music, if you're at, let's say, the B here, this B right here. If you're on this key, B flat is going to be the same as A sharp. Okay, so flat is the same as A sharp, and I think I may have another picture. No, I don't. I've seen other pictures showing that and describing that, but essentially the same thing with, like, if you're at this key, if you're in A sharp is to the right, but A flat is to the left. Okay, so to the left is flat, to the right is sharp. Okay, so that's how you get your flats. Okay, so if it calls for B flat, you're going to go to the B key, and then you're going to go to the black key, but on the left side, the next one to the left, and that will be your A sharp or B flat. Okay, so that's kind of how music in a nutshell kind of works, or at least piano, how it's organized, in a nutshell, works. So this helps with understanding the rest of it. So now we're going to go ahead and go on into here's the melody. This is where you put your sequence of notes. Okay, and you'll see what the zeros are later on. The zeros are rests. How you can have an eighth rest or a quarter rest or half rests or whole rests, and there's all the different types of rests. The zero is basically just a placeholder so that no frequency goes out, but yet the time and the slot is conserved. And you'll see that when I get into the timing portion here in a minute. Here's the size of your melody, and this one is 12. There's 12 entries in the array, so the index of the array. This is important because later on we'll be looping through all of the code and everything. And so when we loop through, we need to know how many that we're going to play. So that's what that's for. Here's our durations. Now, these will coincide, so far as index value, they will coincide exactly with the melody, okay? So you've got E5 here, and that one's a 16th note because it's 16. How this works, just like the comment says, 4 equals a quarter note, 8 equals an eighth note, so on and so forth. 16 equals a 16th note. 1 equals a whole note, 2 equals a half note, okay? So on and so forth like that. So E5 is gonna, I want a fifth octave E, and I want it to only last, it's gonna be a 16th note, okay? Same thing with the next one, is the same one, it's a 16th, but then we get to a 0, okay, on the third one over, and I have a 16 down here. That means that's going to be a 16th rest. The 0 in the melody means we're not going to play anything, but the 16 down here in the note durations means that we're going to wait the same amount of time as if it was a 16th note being played, which therefore gives us a 16th rest, right? That's what you do when you're playing in music. You come to a rest. You wait the same time period, but yet you don't play the actual audible tune. So that's what the zeros are in here. Those are the different rests. And like here towards the end, there's a 4 and there's a 0, so that means I've got a quarter rest instead of a 16th rest, okay? So that's what that means. Now here we go. We're going to declare a button, and we're going to declare it on pin 12. Excuse me. Excuse me, guys. Pin 12. Then we've got a button state variable, which we're going to watch for when the button changes state when you push it. And then we get to our setup function. Our setup function, we're going to set up our pin 12 up here, our button pin. We're going to use the pin mode command or function, and we're going to initialize it and set it to input and pull up. That way it will internally pull it to 5 volts. So that sets up our pin 12, our button pin. Then we get to the main loop. Okay, so we're going to basically read the state of our button, and then based on that, we're going to check to see if the button has been pushed, if it's active low. Then we're going to go in, and I'm putting a while loop in here because if it's a momentary button, which this one is, when you push it, I want to wait till the person takes their finger off the button before I execute the code. A lot of times in programming certain things, if you have it where just the minute they push the button, you start executing code, you can run into the problem of it'll loop depending on how many megahertz your internal clock is, and how fast the instruction set timing turns out to be and things like that. You may push the button and it loop like 10-20 times through that code, and maybe it'll act like you push the button 10-20 times when only in fact you're only pushing it once, because you can't push the button and get your finger off of it faster than, let's say, 10 milliseconds. Well, depending on your instruction set, 10 milliseconds may be 100 executions of your code, so that can happen. So what I do is I create a while statement that says, okay, while that button is pressed, I'm going to read the state of the button. And basically what that'll do is, while the button's being depressed and hasn't been let off of yet, it'll just sit there and be stuck in that while loop. And then the minute they let go of the button, obviously the state will change and it won't be low anymore. It'll go to high, and then it'll exit out of that loop and continue on with the code. And that way you get one single execution of the code that you're wanting to execute with each push of the button. That way you don't get it to loop up. So now we begin our for loop. Like again, remember I said that above here we're setting how many how many entries in your melody has, so that way we can loop through them all. So this is where we're doing it. Starting with our for loop, and we're using our index variable called this note. Then what we're doing is we're calculating the note duration, how long we want the note to play for. And what we're doing on this one is we're using basically common time, more or less. We're using basically 4/4 time. Those of you who don't know what that is, it's 4 beats in a measure, and a whole note gets 4 counts. Okay, so that's what we're basically saying. So basically, you have 4 quarter notes in each measure, in the music. So anyway, we're taking 1,000 milliseconds. Okay, this is in milliseconds, so 1,000 milliseconds, and we're dividing it by whatever our note duration is. Remember, we set up here We set our note durations as 16, 14. That's why we're saying it's 16th notes, is because we're taking 1 second and dividing by 16. So a 16th or a quarter or a half or so on and so forth. Okay. So that's what that is. This is where we do that calculation. Now we're going to check and make sure that the melody isn't 0, because what we're going to do is we're going to play the tone now. If it is 0, you know, we don't want to play a tone, right? So here's where we do the check, okay? And then we issue the tone command. This is a slick little function. You put in tone, and then the first parameter is the pin that we're putting it out, which in our case, you know, it's pin 8. I left it the same. I think the example was still pin 8 as well. So pin 8 is the pin that we're working with. Then the melody that you want to play, what frequency you want to play at, which we'll use our melody array, and then of course we put our index value in, our for loop index, and then the duration for how long you want, in milliseconds, how long you want it to play for, and that's where we put in our note duration that we've calculated up here, we put in right here. And that's all there is to it, and it will play the tone, it'll generate the square wave and do it all. So fantastic. And then of course the else to this if is if it is a zero, or if it is a 0, you know, like up here we don't have a note, it's just 0. Then what's going to happen is we're just going to still delay. We're going to call the delay function. We're going to then calculate the note duration, and we're going to just delay that amount. That's all we're going to do. And we're not going to issue the tone because we don't want to play anything. We'll just delay. And then on down, what this is we're going to calculate the delay between notes. And this is where it can get kind of tricky, and you just kind of got to play with it to get the timing in your music correct. You know, but right now what it's doing is it's taking whatever the note duration is and multiplying it by 1.5, which will basically give you 50% more is what it's going to do. And then we just delay before we let it loop back to the top. We just delay that amount of time. And then finally we call the no tone with the pin number in, and that way it ends that tone playing sequence, essentially. We call the tone function, and then we call the no tone function once it's all said and done. And that's basically all there is to it, guys. I basically just kind of ran through it real quick and explained it. The next video that I'll probably do will be a good old demo video. We'll be demoing this out, and I'll show you that it actually does work. Like I've come to start doing. We'll load this onto an Arduino and we'll play with it. It'll be my Leonardo Arduino that I have. We'll load it onto that and we'll hit play and see what she does. Again, like I said, let me show you how I came up with this melody. I have, hopefully it'll open and it won't freeze. Sometimes this freezes and I don't know why. I don't know, you guys tell me, does your guys' PDF ever get stuck? Mine does. So mine's going to sit here and act frozen. I've got it on my other screen, so you guys can't see it just yet until it unsticks. I may have to pause. Oh, no, there it goes. I don't know. Adobe, you need to fix your deal. Of course, I don't know, it might be out of date. I don't know. Anyway, it's the Super Mario Brothers theme I got from... Alfred Publishers, yada yada yada, musicnotes.com. That's where I downloaded this. That's a great place to go get if you want little snippets of music that you like and stuff. I think you can purchase full scores of stuff, but anyway, I downloaded this from there, so mad props to them. Let's see. But what it is this is the score for Super Mario. So, you know, the good old do-do-do-do-do-do-do, you know, oh, wonderful. So anyway, what I've done is you've got the treble and the bass clef. If I wanted to, I might be able to put another speaker on there, but I think that's kind of the downfall of the tone command, is I don't believe there's a way... Yeah, I don't know how to do it. There's a way to simultaneously play two notes. So like something like this, I don't know if you guys can see that, but this right here... I don't know if there's a way that you can simultaneously play notes. And the same with, like, if you can do the bass clef, you know, in sequence and in synchronization with the treble clef. I don't know, that might take some finagling around to figure out. And that's why you may have to rewrite your own tone function to get that to execute at the same time. But anyway, basically that's what I've done. So you've got, if you look here, I don't know if I can, see if I can twin do this here. Okay. Where's it at? Where are we at? Okay, we're right here. All right, let me get that back. So basically, you've got an E, and you've got 3 E's. You've got the 16th rest in the middle, 16th rest here. Then you've also got your 8th notes, which you've got, let's see, what is that? It's a C and then an E, and so on and so forth. Well, that's what you've got down here in the code. I've got an E5, because that's what this is. This is an E5, okay? And to prove that to you, I've got my little cheat sheet here, okay? There's my little cheat sheet. So it's up there, so that's an E, and that's a 5th octave C, because you've got, remember, middle C is 4, so you've got, to the next C, okay, and you've got, which now that becomes C5, that's the next octave, that's the 5th octave, and then there's the E, okay, so that's a 5th octave E, so that's why I've got E5, and then E5, and then I've got a 0, but I've got 16 because I've got a 16th rest, okay, and then another E5, and then I've got the, let's see, pull that down there, then I've got a C5, because see, again, I've got right here, that's a C, but it's the 5th one, because here's middle C's 4, so C, that's 5, okay, and so on and so forth, and then I've got the 16th rest, and then I've got another quarter note, which that's actually a G. It's not on this scale, but the next one up is a G, but it's a 5th octave G, so that's why it is, I don't have it, there it is, 5G, and like I said, and so on and so forth. And see, that's all you got to do if you want to take your favorite song and put it into this, is do that. Now, I do have some software that, just because I could, I'm making, and it's not 100% finished, but I think I'll show it to you when I do the demo of this code. I'm going to give it to you guys totally free. I'm just going to post it on my project code link, but basically, it's a software that has keyboard keys and things in it and makes it very, very easy to make these melodies. And what it actually will do is it will actually generate this entire code file. It'll generate the entire file. That way, all you guys got to do is just slam it into this Arduino IDE. You'll have to add the .h file with it, which, if you don't know where that is, just look in the examples. Go File, Examples, Digital, and then Tone Melody. We'll bring up, in fact, here, I'm just going to do it. I'm going to click it. We'll bring up the Tone Melody one, and you get the pitches there as well. And you can find those files in your examples folder inside your Arduino install, wherever you've put the Arduino IDE. It'll be in that folder. All you got to do is add this with it, put it in a folder of its own, and you can open it just with File open it, and it will run your music that you've created. So it's a kind of a music creation software, and I threw it together. It only took me about a day to do it, except I need to add a couple more things to it, and it'll be finished. And I'll demo it along with the demo of the circuit functioning, and so that'll give you guys something fun to play with. I don't know. I like music. Music's really fun. It's fun to play with, and what's more fun about combining electronics with music? Those two great art forms, right? All right, guys, this video has ran on long enough. Thanks a lot for watching. Take care. Keep coding and look for the demo video. I was going to do this one in 2 parts, but I figured, what the heck, I'll just ram it all together into one big video. So sorry it took a long time, but I figured it was such a small deal, I'll just put it all together in one and be done with it. So take care, guys. Like, subscribe, share. And with that, guys, that ought to do it. Take care.